Technology has changed how we live, and it is changing how we will live in the future. And hopefully, it's going to be a smarter future. And we all know that engineers are the driving force behind the change by making use of data, by changing data to information. And now we're talking about from information to wisdom to decisions. And this transition plays a really important role in human history. And we're talking about flying cars, and now everything is connected to the internet. We collect way more data than we used to be collecting in the past. So what's next? What kind of opportunities we're creating right now with so many devices connected to the internet, or basically collecting data about every movement you're making, about everything that is happening around the world? What kind of opportunity we're exploring right now? And if you look back to history, like even actually in 2006, you see that the robots deployed in hospitals, in some kind of hospitals in Tokyo, and the robots can actually simulate a receptionist. So when the family of a patient, they come to the hospital, the robots will be able to identify that and guide the patient's family to visit the patients. So you see that machine learning intelligence has been in place in our life for a really, really long period of time. But what's next? And we're so excited to see the upcoming of Internet of Things. We're so excited to see that devices that used to be isolated, now they're connected. So after you got data, after you connect it, we see open opportunities to make these kind of things much, much smarter than before. And we also see that our life will become much smarter. So just to give you two more examples, one is, imagine like surveillance camera. Now you can collect data in tape in a like digital format. But what if the data is collected to a server, to a central server in real time? What if the events data can be streamed to machine learning server in real time, and you can do the data processing immediately? Now imagine, it is really like you're having the police standing everywhere, and not only you know what is happening or what has happened in the past, but with machine learning, you can also predict what will happen. So we're providing the prediction power to devices when they're connected to the internet. The next one is even more interesting. Now, I mentioned that machine learning has been applied previously, like in many applications already. For example, in a city in Germany, they can predict the traffic. They can predict up to 30 minutes in advance of the traffic that will happen. But so what's the role of Internet of Things can play in this kind of situation, in this kind of applications? Imagine if the application of prediction is connected to the traffic light. Now, not only can you predict the traffic, but you can change it by controlling the traffic lights that are deployed around the area that you predict 101 or 280 will have serious traffic problem, and you can divert, you can control, you can change how the traffic lights behave. This kind of opportunities, this kind of potential applications are all enabled by connecting devices to the Internet of Things. So today, because of the limited time, I won't be able to give you a concrete example how we can build machine learning applications with Internet of Things. But I do want to point out a number of things. Probably one is the nature of machine learning, and the second one is what kind of open source tools we can use, we should look at so that we can do the application development easier. So machine learning, it is a hot topic right before Internet of Things, I would say. Like last year is all about big data, it's all about predictive analytics. And by the way, machine learning has a lot of fancy names. Some people will say it's just an advanced data mining. Some people say it's predictive analytics. Some people say it's machine learning. Some people say it's pattern recognition. If you look at it from the application point of view, if they're trying to predict the future, trying to use data to predict the future, basically they're talking about the same thing. It's just like everyone is trying to come up with a fancy name, so just to confuse you, to make it feel like it's a really huge area that no one can understand. But anyway, it's not that complicated. Back in 1959, scholars has already defined this area. Machine learning is a field of study that gives computers, now back then it's still focusing on computers, not other devices. So it's a field of study that gives computers the ability to learn without being explicitly programmed. This is a really powerful statement if we can do it right. Like imagine computer in the past, it's really about collecting data, collecting a lot of data, and you can analyze it, and maybe you can visualize it, and you can define some rules so it can do routine works repeatedly. So it might help humans to handle some tasks if we can give it rules. But what machine learning is saying is computers or devices not only can do things that you ask it to do, it can actually learn by itself through analyzing data to finding patterns in data. And then they can do something that you did not explicitly program it to do. This is a famous data pyramid, I think, in sociology, in psychology, in computer science, in a lot of research disciplines. They talk about the data pyramid. What it's saying is, in the past, data is chaotic. Like, we always have a lot of data. Imagine if you connect the traffic light to the central server, how much information you can generate if you have a sensor with the traffic light. Like the traffic light change, what time the car would pass the line. If the traffic light change, how long does it take for each car to stop behind the before the traffic light? So you're generating tremendous amount of data, but you don't know how to use it, right? So in the past, we focused on automating data collection, but we also focus on dashboard measurement, and eventually we try to provide statistics. Like we want to give a summarized view of what's happening. So data analytics, the main difference, if you ask me, what's the difference between data analytics and machine learning that we're talking today? Data analytics is about telling you clearly what has happened in the past. So it gives you visual report, it gives you summary, it tells you precisely this group of users, this group of customers, this group of people has done this kind of thing, and this group of people has done that kind of things. And now we're moving up the pyramid, which gives us more value. It's about wisdom, it's about knowledge. And with knowledge, you'll be able to predict things. And with predictions, you can change what will happen. So to simplify what we have been talking about, like machine learning, it's just mean things that learning predict from data. As long as you have collected the data and you have a way to process it, you have a way to convert the data to become wisdom that you can apply to predict unknown or future events. That's machine learning. And if you understand the concept of machine learning, you applied it to Internet of Things, you applied it to things, any kind of devices, watches, microwave, lights, smart home, security. You applied the prediction capability to all these devices that are connected. Things will be interesting. So machine learning, if you look at it from the more technical perspective, it is actually very simple. It is an object going into the predictive model, and then prediction output will come out. What is an object? In a simple sense, it can be, in a shopping scenario, let's say like e-commerce scenario, object can be a person. So you might want to predict the preference of the person today, or if it is like the context, if an object is about today, and you want to predict, actually the context is about tomorrow, and if you want to predict the weather of tomorrow, so the object might include different kind of information. It might include data of the past few days. It might include data of the past or today. It might include the wave strength and other kind of information that you can collect about tomorrow. And you send it to a predictive model, and then it will give you prediction. It's just that simple. And of course, the math, the statistic model relies, determine how you build the predictive model. So usually it would be like processing data of the past year, processing data of the past few years, so that you can find patterns, so that you can find wisdom or knowledge about the thing that you try to predict. And you can also have multiple objects input. One example is a classic example that everyone is familiar with. Like if you have shopped online or if you browse movie online, they can predict you as a user, item as the movie, and they can predict a score. Like how likely you will like to buy this product or how likely you will like to watch this movie. So from the programming sense or from the system sense, it is really like you have a bunch of data, you create a predictive model. And for this predictive engine, your input query would be the object or multiple objects, and you will have one prediction score or prediction goal that you want. So what are the output? What can be the output? In machine learning research discipline, people classified it mainly to fill categories. One would be regression. It's a fancy name, but if you think about it, regression and classification, they're actually the same thing. The only difference is regression is more like you want to predict a continuous value. So let's say weather, for example. A regression predictive model means that I want to predict the precise temperature, be it 70, 71, 72, or 72.5. Classification means we have some predefined set of categories, and you want to predict which category the object belongs to. So weather, again, you can predict whether tomorrow's weather will be warm, hot, or cold. So that's classification. Regression is more like a continuous value. And the reason why people need to categorize them, like separate them differently, is because you might be relying on different statistical assumptions. You might be using different algorithms. So it depends on your application, right? Like, you might want to have a really precise degree of predictions about of the outcome, but you might also just want a category, like is it hot, warm, or would the traffic be bad or good, or you want a number of it. It really depends on your design of your applications. And clustering just means you want to automatically categorize things into different clusters. You want to automatically discover the clusters. Which I don't want to go into details now. But going back to Internet of Things, the starting point is really data. And as mentioned, because the device is connected to Internet, to the storage, or to the processing server, what you can do is you can send real-time data back to the processing server. You can collect all kinds of data. But you can also send the data in batch to the server as well. And one side note is, with great power, with the device being able to collect a lot of information, it comes with responsibility. In the big data industry, we already talked about, we have a lot of debates about like privacy, discrimination. Like imagine you just walk to a shop and the computer automatically say, hey, this guy doesn't have spending power, just like ignore him, ignore her. This guy like is a high value customers, spend more effort on it. Maybe it's good for a shop, but I don't know how you feel about it. You might feel good about it. But what I'm saying is I foresee that for Internet of Things cross machine learning, the responsibility, data privacy, discrimination would be a great topic that application developer of Internet of Things would need to be aware of. So talking about building machine learning into your application or into your things, what we can do, of course, we created an open source framework called PredictionIO. The idea is like a search database or search server or like a database server where you can import data, import real-time data into the server through easy-to-use REST API interface, or you can use any of the SDKs provided by us or by the communities. PredictionIO is now powering hundreds applications. We have over 5,000 developers engaged in the open source project. So the whole framework is open source, it's on GitHub. You can take a look at it. The goal is to make development of machine learning into application easier. As you can see, with just one line of code in your application or on your server, you can send the data. Let's say John has visited shop A, or John is going through this traffic light, or like car A is going through this traffic light, or now the weather has changed from like rainy to sunny. So you have all this events data connected to PredictionIO server. And then with one line of code, you can retrieve the prediction based on the predictive model, or based on the predictive engines that you have created behind the scene. It is a flexible open source framework. So unlike out-of-the-box cloud services, which has predefined predictive applications like e-commerce, news recommendations, it is an open framework where you can develop different kinds of predictive engines for, be it regression, classification, clusterings. We provide sample engines, so you can take a look at it and you can modify it for your specific needs. And the reason why we're creating the open source framework is for application developers, or for application of Internet of Things developers, the concern is really the business logics, or the logics of the prediction. And for data scientists who are creating the predictive model, the focus is on the statistic model, the focus is on the algorithms, the tuning of algorithm parameters. And we want to do the heavy lifting behind. We want to do the software engineering heavy lifting behind it. So we provide a horizontally scalable architecture, so you don't need to worry about collecting huge amount of data in real time. You can scale the PredictionIO framework easily. And it is algorithm agnostics. It means that we're actually not a data science company in a sense, or a data science product in the sense that we tell you we have a secret algorithm, you don't know about it, it's the best in the world, you just use it. But it's an open source framework where you can try different algorithms. We integrate with Spark MLlib, we integrate with Apache Mahao, we can integrate with other machine learning libraries easily in a single box of development framework. And the goal is for you to choose and to evaluate which algorithm is the best for your particular applications. Because the research for machine learning, the research of machine learning for Internet of Things, like the predictions for traffic light and the sensor, is still really new. And we don't see a lot of application. We don't see a lot of existing out-of-the-box machine learning solutions for this kind of applications yet. So having an open development framework will help us help the community develop applications, predictive applications together. And so open source is really important in our opinion. And that's why the whole framework is 100% open source. And if you look at the system architecture, you can see that it works really like a database server, except we're not for search, we're not for data storage, but it is for prediction. So through the events server, your application, if you have multiple traffic lights, or if you have multiple lights or home security device, you can stream real-time data into the server through the API, through the event servers easily. And then at the back, you can group the applications with the application's ID, and you can deploy multiple engine instances. Each engine instances represent one configuration of a predictive engine. So let's say you're trying to predict traffic. You can have multiple instances running at the same time, and then you can evaluate which one has the best prediction result. And through the REST API, you can send a query to engine instance, and it will send you the prediction result. So this is a really high-level view of the idea of the development framework that we're building. We won't be able to go through the code and how you can create the engines here, but I'm happy to answer any questions like after the talk. So PredictionIO, again, open source. feel free to take a look. And actually, I'm really interested in learning more about like what kind of Internet of Things applications, devices that you guys are building or you guys are interested in. So feel free to ask any questions or feedback suggestions.
What's the licensing model for this?
Apache license. One last question. I think we're running out of time. Sorry.
I didn't see where you're teaching the engine.
We provide the training scheduler in the framework. So all you need to do is develop the evaluation metrics. We'll automatically tune the engines, and we will run the training model update automatically. And the documentation is on the website. So we can talk more about it like after it.
How do you, what's your business model?
Open source license, so standard open source business model like MySQL. We might provide enterprise edition in the future, we hope, when it becomes a useful product. But at this moment, we really want to make it useful for us. Thank you. Special thanks to the laptop.